Hello! Welcome to today's lesson on constructing ray diagrams for refraction. Our goal today is to learn how to visually represent the behaviour of light as it passes from one medium to another. You are already familiar with the concept of refraction, which is the bending of waves as they pass from one medium to another. Building on your understanding of refraction, we can now learn to construct ray diagrams that represent this process. This skill is fundamental in studying the behaviour of light and will enhance your broader understanding of optics and wave behaviour in physics. Let's go through this step by step. Start by taking your paper and drawing a horizontal line across it. This line represents the boundary between two different media. For example, it could be the line where air meets water or where air meets glass. Label the upper part as medium 1 and the lower part as medium 2. Next, draw an arrow approaching the boundary from medium 1. This arrow represents the incoming wave or the incident ray. Make sure the arrow is pointing towards the boundary where the change of media occurs. At the exact point where the incident ray meets the boundary, draw another line. However, this line should be perpendicular to the boundary. This perpendicular line is called the normal. It will help us measure the angles correctly and understand how the wave bends as it enters the new medium. Now measure the angle between the incident ray and the normal line. This angle is known as the angle of incidence. Label this angle on your diagram. Keep in mind that this angle is always measured from the ray to the normal, not to the boundary. On the other side of the boundary, in medium 2, draw an arrow to represent the refracted ray. This arrow shows the direction the wave travels after passing through the boundary. If the wave is moving from a less dense medium, such as air, to a more dense medium, such as water, the refracted ray will bend towards the normal. Conversely, if the wave is moving from a more dense medium to a less dense medium, the refracted ray will bend away from the normal. The bending direction is essential for understanding how light behaves in different situations. Next, measure the angle between the refracted ray and the normal line. This angle is called the angle of refraction and should be labelled on the diagram. Similar to the angle of incidence, the angle of refraction is always measured from the refracted ray to the normal. To end this lesson, let's briefly recap the key bending rules. If the light ray travels from a less dense medium, like air, into a more dense medium, like water, it slows down and bends towards the normal. This behaviour can be demonstrated by the refracted ray being closer to the normal line than the incident ray. Conversely, if the light travels from a more dense medium into a less dense medium, it speeds up and bends away from the normal. In this situation, the refracted ray ends up farther from the normal compared to the incident ray. These rules about bending are vital because they dictate the path the light, or wave, will follow when crossing different media. In today's lesson, we focused on constructing ray diagrams to represent the refraction of light as it moves between different media. We began by drawing the boundary between two media and added the incident ray pointing toward this boundary. We then introduced the normal line, which is perpendicular to the boundary and essential for measuring angles. We measured and labelled the angle of incidence between the incident ray and the normal line. Next, we drew the refracted ray and labelled the angle of refraction, noting that the ray's direction changes depending on the relative densities of the media. In the next lesson, we will learn about representing refraction with wavefronts. Watch the rest of the GCSE Physics course at Sophos Education.